Okay, so today's lesson is on geometric sequences. It's chapter 9, section 3. Our content objective is to define, identify, and apply geometric sequences, and our language objective is to use the correct terminology to describe and explain them. So let's jump in by actually defining what a geometric sequence is. I mentioned this briefly in a previous lesson, but a geometric sequence is just like an exponential function, or it's when you're multiplying to get the next term in the list. So a geometric sequence is a sequence where the ratio of any term to its preceding term is a constant value, or as we will refer to it, a common ratio. So that constant value or constant ratio between terms is our common ratio in our geometric sequence. So just like we had a common difference in our arithmetic sequences, we have a common ratio in our geometric sequences. So the common ratio we'll define next. That is the constant ratio between consecutive terms. And we'll use the variable r to represent that. So just like we used the variable d to represent common difference, we're going to use the variable r to represent common ratio. So we're going to start with a quick check to make sure you guys understand what I'm saying or explaining with or defining for a geometric sequence. So I'm asking, are the following sequences geometric? So the first sequence I'm going to give you is 3, 6, 12, 24, and the second is 3, 6, 9, 12, 15. So try those out. I'm going to go over those now. Or pause it, go over them. I'm going to go over them now. So first thing I'm going to do to figure out if there's a common ratio, I'm actually going to set up a ratio. So I did the term to the previous term, or the term divided by the previous term, and I got 6 over 3, which is 2. Here I'm going to do 12 over 6, which again simplifies to 2. 24 over 12, again simplifies to 2. So there is indeed a common ratio. So yes, r equals 2. So the first one is because I'm consistently multiplying by 2 to get the next term. So 3 times 2 is 6, 6 times 2 is 12, 12 times 2 is 24. So let's try this with the second one. So I again have 6 over 3, which simplifies to 2. Then I have 9 over 6, which does not simplify to 2. It simplifies to 3 over 2, which already you know that there's not a common ratio. So once you find one that disproves it, you know it's not a geometric. So I'll say no to start. But just to sort of continue the point, here it'd be 12 over 9, which simplifies to 4 over 3. And here I have 15 over 12, which simplifies to 5 over 4. So again, this is not a geometric sequence, so no, there is no common ratio. Some of you may have noticed it's actually arithmetic because you're adding 3 each time. So you could write an arithmetic explicit formula for that, but it is not geometric. So now let's go into some of the actual formulas for geometric sequences. So we're going to start with a recursive because that's just defining the pattern we're naturally doing to get our list or to form our list. So our recursive formula, we can find a term by taking, so an or a sub n, a term is equal to a sub n minus 1, or the previous term, times the common ratio. So our recursive formula for any geometric sequence is just taking a term and multiplying it by our common ratio to get the next term. So to get a term, you take the previous term, multiply by the common ratio. And this only works when n is greater than 1 because you have to have at least one term to get started. What's going to be more important and more useful for us in this lesson is our explicit formula, which is again going to be a sub n, or a term, is equal to a sub 1, the first term, times the common ratio to the power of n minus 1. So notice the n minus 1 here is all in the superscript, it's in the exponent. So I'm taking my first term and multiplying it by my common ratio a specific number of times based on which term I'm solving for. So this works for when n is greater than or equal to 1, so it can help you find, or it'll give you the first term and every term thereafter. Just a quick recap, we've talked about most of these variables already because they represent the same things in our general sequences, our arithmetic sequences, and still the same here in our geometric. But a sub n is the value of the nth term. A sub 1 is our initial or first term. R is going to be our common ratio, as we talked about earlier. And n is the term number or the placement in the sequence or in the list of numbers. So again, these are all, or most of these are variables you've seen before in our examples. The only one that's new that we mentioned earlier is our common ratio. So I'm going to flip the page to do an example. The example we're going to start with is what is the 10th term of this geometric sequence 4, 12, 36, so on. So pretty much identical steps to our arithmetic sequence problems like this. We're going to start by identifying the variable values for the explicit formula. So again, my formula is an equals a1 r to the power of n minus 1. So variable values I know my first term, a sub 1, is equal to 4. I can figure out that my common ratio, so I'll again put this note here if it's helpful. Your common ratio, if you want a specific formula to follow, is going to be a term divided by the previous term. So if you can just logically see 4 times 3 gives you 12, 12 times 3 gives you 16, you can say that r is 3. But if you don't see that pattern on your own, you can strategically just do 12 divided by 4, get 3, 36 divided by 12 gives you 3. So you know your common ratio is 3. And since you're finding the 10th term, you know n is going to be 10. So then we're going to substitute those values in. So when I substitute those in, I get a subscript 10 is equal to 4 times 3 to the power of 10 minus 1. So then it's just simply evaluating or calculating that out. So I end up with a10 equals 4 times 3 to the 9th, which one you can plug that in your calculator or use your power sheet to get through the 9th, then multiply by 4, and you should get 78,732. So a sub 10 is 78,732. So if you continued this list out to the 10th term, that is what should be there. All right, I'm going to skip the quick check for this. We'll practice that in class some more. So I'm going to jump into another type of example, which is again similar to the ones we did in our arithmetic sequences notes. But I'm going to ask, what are the second and third terms of the geometric sequence 2 blank blank negative 54. So first thing we're going to do, again, just like our arithmetic sequences, we're going to identify known values and variables. So I'll rewrite our formula just so we can have it for reference. I know the first term or the initial term is 2. I don't know my common ratio, but I do know the fourth term, so a sub 4 is equal to negative 54. So it's the fourth term in the list, and it has a value of negative 54. So I'm going to substitute, I, again, do not know my R value, so I'll put a question mark for that. So I'm going to substitute for the information I have. So I know negative 54 is equal to 2 times R to the power of 4 minus 1. So again, this was my n value I plugged in. This is the value of that term. 2 is my initial value, so I plugged it all in. And now I'm going to solve for R. So I'll start, again, this is we practiced solving these types of problems previously, but I'm going to divide both sides by 2 to isolate the base. So divide by 2, and I get negative 27 equals R to the third. And so then I'm going to cube root both sides to get R by itself, and I get negative 3 is equal to R. So now I've solved for R, and I can use that to find my two missing terms. So I'm going to use the common ratio to solve for my second term and my third term, so a sub 2 and a sub 3. So a sub 2, all I'm going to do is do 2 times negative 3, and I get negative 6. To get the third term, I'm going to do negative 3 times negative 6, and I get positive 18. So those are the two missing values in that list, or the second and third terms for that sequence. Let's do a quick check for that one. So I want to know what is the second term, just the second, of the geometric sequence 3 blank 12. All right, so try that one out on your own. I'm going to go over it now. Again, I'm using this same formula up here. I know my first term, or my initial term, is 3. I don't know my common ratio, but I know my third term is 12. So I substitute in what I know, and I say 12 equals 3 times R to the power of 3 minus 1. If I simplify that, I get 4 equals R squared. If I square root both sides, I end up getting R equals plus or minus 2. So again, this can be a little tricky because now I actually get two potential values for my second term, because if A was, if R was positive 2, I'd end up with positive 6 as my answer, but if it were negative 2, I'd end up with negative 6. So the second term could be positive or negative 6. And this checks out because if I multiplied, if it were negative 2, so if R were negative 2, negative 6 times negative 2 brings me back to positive 12. So there's no way of knowing if that middle term was actually a positive or a negative value. So that's a little bit tricky, but since there's only 3 terms, the middle term could be plus or minus. So there's, actually that'll be all for today. We'll go over the geometric mean in class, but that's all for today. Make sure you write down any questions, comments, or concerns you have on this so we can go over it together in class.